Hey, hello guys. I hope you guys have a good day. Just to explain you, I try to leave a link, or I say in Spanish means enlace, so you can download the files of this project. This PCB was designed by Mr. Willie. Mr. Willie, he's the one that create the PCB. The only thing I did, I just adjusted just a little bit, but all credit belongs to him. So, and the only thing I did, I just fix it. Not fix it. I mean, it just adjusted a little bit. So I like to make the PCBs look really nice. So I decided to continue with this, with his job, and send the file so you can try it out. This amplifier. One advice about this circuit, it might be a bit dangerous, so you gotta be careful if you're working with high voltages, because this amplifier I think needs like 110 volt DC, and that's a lot of voltage, so you gotta be careful with this circuit. But you can also work with this circuit with lower voltages, so you don't need actually to work with 110 volt DC. I can show you a demo with the simulation. One thing that I want to clarify here is that let me fix this thing. I think my USB drive is not showing here, so let me fix it right away. There you go. So okay, one thing to note. Then do I have it here? Let me see. I got too many simulations here. You gotta be careful with that simulation. I think I have it on the folder, because it works with really high voltages, so you gotta be careful with that. So like I say, it's a pretty dangerous circuit when you're working, but you can work with this amplifier with lower voltages. But one thing that to note is that you cannot apply more than 1.5 volt peak. 1.5 volt peak is as an example, it's like you have a radio receiver from the car audio. The car audio will have a few RCAs. It will send a signal to the input of the audio amplifier. I think they can go from 1.5 volts, maybe even more, maybe 2 volts, to excite the power amplifier. So I'm going to show you an example. So you gotta be really careful with this thing. Okay, one example. If you don't have a transformer that they can supply about 95 volts DC, you can work with less, probably 65, 55 probably, but it might be too not enough voltage for the supply of the power for the amplifier. So I'm going to show you right quick. Let me use the calculator right quick. Calculator. For example, you have a transformer that is like, let's say 40 volts AC. You multiply that for 1.4.42. I always use 2. Let me see how much I got. 56 volts. I think you can work it with 56 volts, probably 60, 65. It will work, but you cannot push the amplifier to give that 1000 watts, so it's not going to be possible. So you need to have more voltage in order to achieve the power in watts. Right now I'm going to change the value. Let's say that we have 55 volt DC, because that's all we got. 55 volt DC, that's all the voltage that we can achieve from that transformer. Also, the transformer has to be a probably, if you don't have a big one, probably 850 VA volt amps. You need to have one larger transformer in order to achieve that power. You cannot, okay, one example, you cannot create power from the air, so you need to have a really large transformer with a larger number, a VA number, volt amp. In Spanish it's voltiampere, so you gotta keep that in mind. So that's really important right there. So okay, here in the simulation I changed the voltage, supply voltage, to 55 volts minimum. 55 volts minimum, can be 60, 65, 75 also. The load is 4 ohms. I had to lower the input because it's gonna reach the clipping. You don't want the clipping. The clipping is the first killer of woofers. That's the first the Green Reaper for the woofers, so it's gonna kill it right away. So you gotta stay away from the clipping. That's a really dangerous situation right there. Right now I'm going to activate the simulation. Let me see how. I hope I don't have a clipping. Let me see. I don't think. Oh shit! Sorry about that, guys. I forgot to change the input to millivolts. Right now, I changed it to 300 millivolts just to be sure that it's not going to reach the clipping. Let me see. Don't mind about the anomaly. It's going to do that, so don't worry about that. Okay, right now I'm going to push this amplifier a little bit more. Let's go with 900, probably 900 millivolts. Let me see. 900 millivolts. So don't mind about that. That's an anomaly. Okay. Okay, as you can see right now, I have 200 and about 300 watts, 297 watts right now, with only 55 volts. So it will work with lower voltages, but the only thing you gotta do is you need to adjust the bias correctly. So that's a really important thing. Probably I will adjust it to 25 millivolts across one of those emitter resistors. Let me see. I'm going to, let me see if I'll be able to adjust the bias. Let me see. I need to show you the experiment. So let me complete this first. So now I'm going to change this to 1 volt peak. 1 volt peak. The input sine wave. Let me show you right now, right, guys, so you don't get confused. So this is the input. One example. This will simulate like the car radio receiver. Is sending 1 volt peak, 1 kilohertz sine wave. I'm not doing the lower frequency. I'm only doing the 1 kilohertz. So that's the best thing to show the power, the maximum power in output of the amplifier. Then, god damn, my English is all messed up. English is my second language. That's why I sound so differently. So different. Sorry about that. Let's say let me activate the simulation. Let me see if we can get plenty of power. Okay, that's clipping. That right there is not good. Okay, it's clipping right now because it does not have enough current for the supply for all the transistors. So now it's going to reach the clipping because that means it's not going to amplify anymore. So that's the limit of the amplifier because you are using a lower voltage power supply. 55 volts, right? You can see right there 55 volts is not enough for this amplifier, but you can actually work with that. So you can lower the input so you can get rid of that clipping. Right now, let me go back. Oh, there you go. So now you don't see no clipping, and it's giving you about 330 watt. That's pretty good. 330 watt on the on this amplifier is pretty good. Okay, now to show you guys, I'm going to change the voltage. Let's go with one example. So you have 75 volts DC of the power supply. So I can increase the volume, the input right now. So I'm going to activate this. All right, there you go. So now I'm going to activate the simulation. Okay, don't mind about that anomaly. That's normal. Don't worry about that. So the amplifier is already being built many times, so I don't think it's going to be any problem right there. Right, there you go. We have 331 watts. I forgot to mention about the total amount distortion. It's pretty decent. It's not that bad. We have 0.038%. That's not bad. That's not really bad. Now I'm going to increase the volume of this design circuit simulation. Okay, let's go to 1 volt peak. Okay, we're getting closer to 1 volt peak, 999 millivolts. Okay, 1 volt peak. Now we have 368 watts. The total amount of distortion is still low, it's pretty low. 75. As you can see, you can work it with 70. I'm sorry, god damn it! It's so difficult for me to explain that again. Jesus Christ. 75 volts DC. Now I'm going to change the value to the power supply. Let's go with 90. Let's say you have 95 volt DC. With 95 volt DC, you can get more power from this design. So I bet you that Mr. Benmira knows about this stuff. He's been doing that. He's been doing that for a long time, so he knows this stuff. He knows. Okay, now I'm going to activate the simulation. Don't mind about the anomaly. That's normal. Right now we have 95 volts on the power supply because this is going to drain a lot of current. We have 378 watts. the total amount of distortion is kind of low now. It's 0.021%. That's pretty good right now. Now I can increase the volume. Let me increase the what is the scale here? 50 volt scale. Okay, 50 volt scale. Now I'm going to increase the volume here. Let's say 1.1 volt peak. There you go. So okay, we have 446 watts. The distortion is low, still low, 0.026. Okay, now let's go. I'm going to increase the volume. 1 kilohertz sine wave. 1.2 volts. We have 530 watts. As you can see, you can actually make this amplifier work with 95 volts right now. Okay, for example, if you are going, okay, I do not recommend this. If you have plenty of experience on this, you can go with 110 volts. For now, you can actually work it with 55 volts, 65, 75 volts, maybe 85, 95. So you should be fine. You should be fine. But you gotta keep in mind that you will have a limit because you don't have enough voltage. You don't have the 110 volts. If you are going to choose 110 volts, you gotta be really careful. You have to make the power supply with capacitors in series. So series. Did I say that right? Series. Oh my God! Did I say that right? Jesus Christ! 1, 2, 3 microfarad. So you will have to place a few capacitors. No, that's not the one. That's not the one that I use. The reason I'm making this video is this is really interesting. I have been studying this for a long time, but probably 4 or 5 years probably. I'm not an expert on this subject, but I always try to do my best, you know, always read and stuff like that. Right now you have to place the capacitor this way. You have to copy it. You have to place the capacitors in series, right, like this. Let me do something here. I'm gonna copy this. No, in series, something like this, as you can see, and you have to place another set of capacitors. It might be a bit expensive to do, but actually you can actually work it with less capacitancia, farad, microfaradians. There you go. So something like this, and then you will connect all these like this, as you can see. I need to find a bridge rectifier. Let me see. What the hell? Oh, there you go. So let me go with 50. Hey guys, I never thought that I'm gonna be able to do this. A long time ago, man. I remember when I started like a few years ago. I really wanted to build my first amplifier. I have not built a larger powerful amplifier yet, but one day probably I will make a really powerful amplifier. For now, I'm just you know showing you guys this so you can take advantages of this. So let me see. Now, I need a bridge rectifier right now. A bridge with let me see. I need a bridge, not bitch, bridge. What the hell? Okay, let me see. Let's see if I can find one that can be used here. No, that's not gonna work. 35. Oh, there you go. 35. So it's gonna be like this. Okay. I need to look at the schematic. The schematic of the power supply. It's right here. I already sent the file. Also, wait. Hold on. I also sent this version of the power supply. You can use this one here. So I send you the file so you can make this one here. Mr. Willie, he also made another one for supply voltage. I think it's here. This is Mr. Willie's design. You can use this one here for the amplifier. You can see you can use it for the 2 channels. Right now 110 volt DC, but you can actually feed it with less voltages. So yeah, but right here is the connection, but you can actually use lower voltages. You can use probably 40 volts, 60 volts. I think 60 volt might be too high. Let me see. I gotta make sure. 60 times 1.4142. Let me see how. 84 volts. Yeah, you can actually work with 84 volts. It will reach almost 90 something volts. Remember, after you have the capacitor, it will increase the voltage probably 10%. It will increase the voltage 10% after you have the filtering. So this is Mr. Willis PCB. He got the black and white, so you can etch it at home and you can build your own power supply for this design. So this is Mr. Willis power supply. Right now, what I was doing? Let me see the schematic. I think you got the idea. I don't have to make it. You can see this is the illustration right here. So you can see that they are in series, so they can withstand that higher voltages. So, but the problem about the series capacitor, it will lower the capacitance. So instead of having the 10,000 microfarad in series right now, it will split in half. Split in half means that it's going to be 5,000 microfarad. So it's going to be half of the values right now. So I had the formula and all that stuff, but that's I really don't need it to. So this is the schematic of the power supply. But you don't have to worry about it because Mr. Willie, he already made the. God damn it! Where is the folder? I lost it. Yeah, I just show you that folder. Don't worry about that. So God damn. I try to do my best, but it's so difficult. Yeah, I guess you guys got the idea. So you can actually work with lower voltages. This amplifier. I think this is a great design. The only thing I need to figure out is the bias string pad that I have. Let me see. The bias string pad, I think I have in a folder here. Let me see. The bias string pad. It's this one here to adjust. That's to adjust the bias. This transistor right here, the Q6 BD681. If you don't have that available, you can use BD139. And don't forget about the leads orientation, emitter, collector, base. So don't forget about that. So, and this one also you can use a different type. Or you don't have this one 2S1837. You can use a different type of transistor. You can use the. Let me see. I always check on the. Oh yeah, I forgot to make the share file link. Jesus Christ. Create link. So like I say, if you are going to build this design, if you don't have enough experience, please do not make this amplifier. If you don't have enough experience, or you can try it out. You can build it. You can build it and just place one pair or two pairs and go with lower voltages just to test it out first. Use a light bulb to make sure you don't have errors, and test it out like that. If you see that it's working fine, then you can continue installing the rest of the power transistors. So it's gonna look like this way. You can install it this way or with the U-type heatsink. I forgot the U-type heatsink. I have the images here. So some guys that build this amplifier. This is the heatsink that I call it the U-type heatsink. So this is the one that fit. It will work with this PCB, as you can see. Sadly, here in Puerto Rico, I'm not gonna be able to get one of these heatsinks, so that's why I cannot build it. Or actually, I can just a really huge piece of aluminum to install it in this particular way, so to test it out. So like I said, you can build it. You only use you gotta use this one here is the driver transistor. So you gotta install 4 of these. For example, I'm going to highlight these 4 transistors. You can test it with less transistor just to make sure you have everything correct. Go with lower voltage, probably 55 volts, to test it out first. After you see that it's a successful test with the light bulb and all that stuff, and then you can continue installing the rest of the power transistor. As you can see, I highlight them right here. All the rest of the power transistors, they are right there. And this transistor, you can use a different type. I always, let me see, on this, I think on the simulation I have a different one. Let me see, I have this one here. You can use this one here, MJE15033G. So you can use this one here. That's Q5 Let me see, Q5 is this one here. So you can actually use it here. On the simulation I have different type of transistor. On this one here, Q4 is this one here. Let me show you the Q4. Q4, okay. Q3, Q4. This is Q4. That's weird. Q3. Let me see. Gotta make sure. Q3. Oh, there you go. They are okay. That's good. That's good. The emitters, so they are the same. They are the same transistor. Q3 and Q4 are the same value, component value. MGS 150. Oh my God, my Spanish is coming out. So that's the one. So those emitters that are together, as you can see, let me see. I'm gonna test here. So the emitters that are together, as you can see, that's the two transistors that are together. So you can use this part number, MJE 15032G. There you go. Oh my God, man. I'm running out of words. So this is the Q6. This is the Darlington transistor for the bias. One thing that I noticed on some guys that build this amplifier, that they, for one reason, they bypass the trim pad. I don't know why. Maybe Willie knows. So okay, this is the driver board for that particular amplifier. Someone made this one recently, a few weeks ago probably, and you can see here on the trim pad, I noticed that there is like a jumper here, so probably you can use it with the bias, trim pad to adjust the bias, or just bypass that and no bias. So that's kind of weird. This image here is when he was testing the driver board, as you can see on this image here. Let me see if I can zoom here. As you can see, there is a wire right there, so probably he didn't want to use the bias adjustment. I don't know, that's kind of like a weird. So it's here, as you can see the bias. Probably I have to do that, the same thing. Oh, one more thing. Yes, I don't think that it doesn't matter, but it's okay, don't mind about that. I'm about to place another pad here, just in case you don't have that special trim pad. I'm not sure if I want to do it right now because I already sent you the file. It's okay, guys. Don't mind about that. So like I said, you can work with you can make this amplifier work with less voltages, and probably here the negative feedback, I changed it to 55K just to get a little bit more power, more sensitive. But the value of this resistor is 33K. I think it's the 33K, the original value. So it's right here, 33K. I changed it to 55K. You can use 47K. The higher the number, is going to be more sensitive, but I do not recommend it to change it right away. Try to use it 33K first. If you have experience, you can change it later to higher values, so you can get more power from this design. All right, okay, guys, that's it. I'm going to save that link. I'm going to post it in my my page, Facebook page, so you can download it. Let me know if the link works, so because I will have many people asking me for the file. So what I'm going to do, I already did it, but I'm going to make the link again. I forgot if I made it. Okay, right here, create the link so I can share that file, and then highlight it and copy. There you go. So I can, let me see. Oh, okay, I send the file. Okay, well, like I said, be careful if you have on one sample, if you have plenty of experience building audio amplifiers, you can do it. But if you don't have enough experience, experiencia, en español es experiencia. Be careful, guys. Be careful. Don't go crazy with that. So let me go now. I'm going to upload these videos to you guys, and then let me, if any question, let me know about the power supply. I think you will have plenty of information about this design. All right, guys. Have a good day. I hope you like this video. Subscribe to my channel. Give it a like and share the file. And I hope you guys have a good day. And my English is so messed up. All right, guys. Have a good day.